Good morning, everyone. Happy Friday. I hope that you've all had a pretty good week at your homeschool. I know it's been a little bit weird, so to try and help us out again, I'm going to go over the math skill review from week 1 today. So it's going to show up as a PowerPoint. I'll also post the PowerPoint to the Google Classroom so that you guys can see what I'm talking about step by step. But if you follow along, there'll be some videos, some that will pop up with the answers for you, and it kind of shows each step you need to take. And of course, too, in the video, I'll be talking to you about each step, just like we would if we were at school. So if you've already got it done, like some of us do, and you want to watch just to check your answers and make sure that you're doing it right for the next time, by all means, go ahead and do that. And if not, it's fine. This is just supposed to help us check our work and make sure we're doing okay. So we're going to take a look at the math skill assessment, which is from the week 1 math lesson. So throughout the video, you're going to hear things from some videos that might remind us of definitions. We're going to see some actual definitions from our math word wall. So let's take a look. So the first question asks you to write 2 multiplication facts for the fact family 3, 4, and 12. We've talked a lot about fact families, being that they're typically 3 numbers that you move around in different ways so that you can make true number sentences. So something times something has to equal 12 because we're talking about multiplication facts. And if we're talking multiplication facts, the ending number is going to be the biggest number. When we do division, the biggest number has to be within the actual number sentence. So let's take a look. 3 times what? The only other option is 4, and then we can use our other way to do this, which is 4 times 3. So if you check your work and you've got that right, you're good to go. Question 2. Kayla has 9 times as many flowers as Heather. Kayla has 45 flowers. How many flowers does Heather have? So we have to think, how can we solve this problem? Remember that the multiplication and division are opposites. So we have the strategy of 9 times as many flowers as Heather. And if Kayla has 45 flowers, we have to figure out that missing number, which is how many flowers Heather has. So it's going to be something times 9 equals 45. And that should be a super quick fact. I've seen some people turn it in where they've done it different. They've done 45 divided by 9 because they remembered that multiplication and division are opposites of each other. So the answer could also be the 45 divided by 9, which would be, I'm going to go back, 5 times 9 is 45. Not sure why it's not showing up. Or 45 divided by 9 is 5. All right, so then we have Mrs. Miller and her 30 students. Half of her class is boys, and out of those boys, 9 have brown hair. So we want to know how many boys in her class do not have brown hair. So first we have to think, how can I solve this problem, and what strategies do I have? I think that we can use our word problem knowledge to figure this out. So we have to stop first and think, because there is more than one step to this problem. We don't know how many boys are in her class. We just know that half of her class is boys. So unless we know really quick 30 divided by 2, we're going to have to do an extra step. So out of those boys, which we're going to find to the answer to this problem, which is 15. So of 15 boys, 9 of them have brown hair. So it's 15 boys minus 9 with brown hair equals 6 that do not have brown hair. So go ahead and check your work. We need to list the factors of 12. Remember, the factors are numbers that you multiply together to get another number. Okay, it's a little bit different than a multiple because 3 and 4 are not multiples of each other, like in the example up there. So 3 times 4 is 12. So we need to list the factors of 12, and thankfully our definition gave us 2 of them, 3 and 4. We always know that 1 is a factor of every number, so there's the first one. Then we have 2, because 12 is an even number. 3 and 4, we already said. 2 times something has to equal 12 if we're making our factor rainbow. And that would be 2 times 6. And then 1 times something else has to equal 12, and we should know that that is 1 times 12.
That's right. Make a pattern. Make a pattern. Let's make a pattern. All right.
All right, so when we complete a pattern, we have to look at the differences between each set of the pattern. So in the pattern up above on the definition sheet, it's triangle, circle, triangle, circle, triangle, circle, triangle, circle. So we know there's only two parts of our pattern. The number pattern below, they're multiplying by 2 each time. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and so on. So in our pattern, we have 3, 5, 7, 9. And you have to think of the rule for how they're trying to figure out their pattern. So the first number we have is 3. The second we have is 5. I can't multiply anything times 3 to get to 5, but I can add 2 to get to 5. So I think that the rule I want to check out is adding 2. So let's look at 5 plus 2. Would that equal 7? And then 7 plus 2, would that equal 9? Okay, so I think that the rule I want to check out, because I think it's going to work, is adding 2 to the previous number. So if I add 2 to 9, I should get 11. And if I add 2 to 11, I should get 13. And if I add 2 to 13, I should get 15. I could keep going, but of course the review only asks for these 7 numbers. So if you want to keep going, keep going. If not, that's fine. All right, number 6 asks us to write 777 in expanded form. So the example gives us 300 plus 20 plus 6 to get 326. So we need to write it out using place value. We need to figure out what does each digit really stand for. So that should be 700 plus 70 plus 7. Now we need to use less than, greater than, or equal to compare. We have to make sure that the open side of our sign goes towards the bigger number. We've been doing this for a really long time. 354 and 357 are my numbers. So if I write it out as 354 is less than 357, I would be correct. My bigger side of my sign is open towards the bigger number. All right, so they just reminded us of our rounding rules. Okay, so less than 5, round down to the ground. Bigger than 5, round up to the sky. So we need to round 63 to the nearest 10. So I need to look in the tens place where I have my 6. That's either going to stay as a 6 or move to a 7. And it all depends on this 3. If this 3 is less than 5, which it is, we're going to round down, which means we're going to keep the 6 the same. We cannot change it to a 5. Okay, it has to go down to 60. Now we're going to round to the nearest 100. So again, we have to look in the hundreds place, and we look next door. This 8 is either going to stay at an 8 or it's going to move to a 9. We look next door and we find a 4. 4 is less than 5, meaning that the 8 will stay the same. So it's going to be 800. You cannot forget your rounding rules when you do these. The aquarium has 247 stingrays and 890 crabs. How many more crabs do they have than stingrays? So we have to think, how can I solve this problem, and what keywords are in the problem that I know will signal an operation? The first one I see is how many more. So I know that I need to subtract 890, because we always start with the bigger number when we subtract, minus 247 would give us 643 more crabs in the aquarium than stingrays. Now Elizabeth can type 30 words per minute. Jake types twice as fast as Elizabeth. How many words per minute can Jake type? We have to think, how can we solve this problem and what keywords do we have? I see twice as fast, which means to me that we're going to multiply. 2 times as fast as Elizabeth. So 30 times 2 we should know, because we can multiply 3 times 2 and put a 0 on the end. So he can type 60 words per minute. Cheryl has 35 friendship bracelets to share with her 6 friends. If she gives each friend the same amount, how many will she have left over? So I have to think, how can I solve the problem and what keywords do I have? I see that she's going to give the same amount to each friend, which means we need to split them into equal groups. And I also see the words left over, which means I think we might have a remainder. Remainder would signal division. So 35 divided by 6. And I know I can't do that because 5 is a prime number. 3 is also a prime number. So there's 2 prime numbers in there. And if a number is prime, the only factors are 1 and that number. So 6 can't be a factor of either of those. So it should be that Cheryl can give each friend 5 bracelets and still have 1 left over. Okay, so we need to talk fractions now. And this is an image that you are going to see in the fraction video, or you may have already seen if you watched it. So equivalent fractions are different fractions that represent the same number. So up in the example, they show 1/2 and 2/4. 1 is half of 2. If I add 1 plus 1, I get 2. And 2 is half of 4. If I add 2 plus 2, I should get 4. So the problem we're tasked with solving is 1/3 equaling something over 9. So the way we need to look at this is kind of similar how the video explains it. You need to find out how many times pretty much 3 fits into 9. And when I do that, we're trying to find 3 times something equaling 9. And 3 times 3 equals 9. So if you've watched my video, you've heard that anything you do to the bottom in a fraction, you also have to do to the top, meaning that 1 times 3 is how we're going to find that question mark. And if I multiply 1 times 3, I get 3. So the answer to my problem should be 1/3 equals 3/9. So this is straight from the video that I shared about how to solve fractions, which is also linked to Google Classroom. So this is going to tell us how to add fractions. Different ways we have to think about this. If your denominators are the same, like 1/4 and 2/4, you're good to go. All you have to do is add across the top. But if your denominators are not the same, you have to stop. I don't mean stop for good and give up on the problem. I mean we have to think this through. There's a certain way we have to do this. We need to get something called a common denominator. Common means the same. Okay, so that means we have to have the same denominator. You might be asking, Miss Wilson, how do I do that? You need to teach me that first. Here's how you do that. We need to find something that can multiply by 10 to equal 20. Again, that should be a super fast fact. Okay, we should get 2. So if I multiply this times 2, it becomes 20. Okay? 20 and 20 are the same, so I now have a common denominator. But remember from last time when I was talking about equivalent fractions, whatever I do to the bottom, I have to do to the top. So if I multiply the bottom by 2, I need to multiply the top by 2 as well. So now I have this new fraction with 2 common denominators that I can add together. And it should look like this. 4/20 plus 3/20. And I learned up top that if my denominators are the same, I add across the top and I'm good to go. My denominators are now the same, so I add across the top. 4 plus 3 is 7/20, which was my new common denominator. So here's a problem you're going to see on your review paper. 4/10 plus 3/100. It wouldn't make much sense for us to change the 3/100, so we have to change the 4/10. 10 times something has to equal 100. Okay, that's another super quick fact. If I think 10 times 10 equals 100, I should have a common denominator of 100. Whatever I do to the bottom, I have to do to the top. 4 times 10 equals 40. So now I should have 40/100 plus 3/100. Once I have a common denominator, I can add across the top and I'm good to go. So 40 plus 3 is 43/100. You cannot forget your denominator. In order to have a fraction that looks smart, sounds smart, you need to have a numerator and a denominator in your answer. Otherwise, it won't make any sense at all. because if I were to draw a picture of this, it would be 100 equal sections, and I would be representing 43 of them by coloring them in. Means the same as 43 over 100. So the answer that we should have then, like I said in the video, is 40 over 100 plus 3 over 100, equaling 43 hundredths, because I can add straight across the top to do 40 plus 3 and keep my bottom number the same. So we're going to let Miss Wilson, once again, tell you how to compare fractions. 100. Okay, so we need to talk about comparing fractions now. So we've talked about comparing numbers before with the greater than, the less than, and the equal to, and the alligators and all that. So now we're going to figure out how we can compare fractions. On our review sheet for week 1 work, we have 1/2, trying to figure out if it's greater than, less than, or equal to 4/5. Okay, so one way we could do this is draw a picture, but if you're like me and you kind of struggle to get things even sometimes, that may not give you an accurate answer. Because you have to make sure that you have 5 equal parts of the shape, and sometimes it's hard to get 5 equal parts. So here's a better way we can do this. Just like when we tried to find a common denominator to add fractions, we can find a common denominator to compare them. Okay, I can't multiply anything times 2 to get 5 equally. So I could find a number that would be a multiple of both of these. Okay, so the first one that pops into my head is 10. 2 times 5 is 10. And anything I do to the bottom, I have to do to the top. So 1 times 5 is 5. Now, how am I going to get my 5 to 10? I'm going to multiply by 2. 5 times 2 equals 10. Do the same thing to the top. 4 times 2 equals 8. So my new fraction then is 5/10, which if we had our equivalent fractions would mean the same thing as 1/2, equaling 8/10. Those two things don't equal up, so I know for sure we can get rid of that option. Now all I really have to look at is the 5 and the 8. Which one is greater? That's the way that we need to open our alligator's mouth. Okay, if we read this as a sentence, it would be 5/10 is less than 8/10, because our mouth needs to be open towards the larger number, just like if we were comparing numbers earlier in the year. Okay, so 1/2 and 4/5 are two numbers. So 1/2 is less than 4/5. All right, let's take a look at question 16, which is adding fractions. It gives you 3/4 and 7/4. So we need to figure out, okay, I need to add across the top because I have a common denominator. So I should get 3 plus 7 is 10 over 4. And if you reduce it, you could have 2 and 2/4. All right, so we're going to look at adding fractions. So this will be the mixed number that we end up with once we reduce the fraction. So here's what it's going to show on your review paper. I'm going to let myself explain it to you so that we can talk about it in a minute. Okay, let's talk about converting mixed numbers so you're set up for success when it's time to do your review packet. So a mixed number is a whole number and a fraction combined into one mixed number. So if I look at my example of 3 and 1/4, my whole number is the 3, my fraction is the 1/4, and they're put together. But sometimes I need to know how to add these two things together. Or maybe I need to make it a improper fraction, which would be where I have a bigger number in my numerator than in my denominator. So let's take a look at how to find that. If I'm looking at 3 and 1/4, I multiply 4 times 3, which is 12. And then I add the answer to that, which is 12, to the 1. So I multiply the denominator times my whole number to get a new answer, which was 12. And then I add 12 plus my numerator, which was 1, to give me 13/4. So now I have an improper fraction where I have a greater number in my numerator than in my denominator. Let's try again. 2 2/4, which means the same as 2 1/2 if we're looking at our equivalent fractions. I multiply 4 times 2, which gives me 8. 8 plus 2 more is 10. So my improper fraction is 10/4, 10 being my numerator, 4 being the denominator. So you can convert them on your review packet. You have these two numbers and they're wanting them added together. If I added them together, I could do 13/4 plus 10/4. My bottom stays the same because I have a common denominator. 13 plus 10 is 23. All right, so 23/4 is what we're left with. And if I were to reduce that, which we'll talk more about later, if I was to reduce that, I would end up with 5 whole sets of 4 with 3 left over. So it kind of becomes like division. If I were to divide 23 by 4, I should get 5 as my quotient with a remainder of 3. And that's kind of what we were getting at when we were talking about division a couple weeks ago. So now we want to subtract doing the same thing. I need to multiply 5 times 9 to get 45, and if I added 8, I would have my fraction over 9. Then I would need to do 9 times 3, which is 27, plus 2 is 29. So I should end up with 24/9, or 2 6/9 if I divide 24 by 9. Last but not least, we need to draw a picture to represent 5/4. So 5/4 would be 1 1/4, meaning 1 whole and 1 colored in out of 4. So there's my whole. I have all 4 colored in. So that's this 1. But then I have to color in 1 out of another 4. So I have a whole and 1/4. So I hope that that was helpful for you. And if you think that you could use this in the future to help you with your next 2 weeks' work, I would go ahead and do that. I'm going to try and get the slideshow up for next week and get it running so you guys can check your work again. Next week I'll also be posting some other videos, so keep an eye out for those. If you have further questions or are still confused by some things, let me know. And then don't forget to have you or a parent send me pictures of your work so that I can make sure that you've done it and you're on track and all good to go. Have a great weekend, everyone.